Hello everyone, welcome to Gain Margin. Today we are going to learn the concept through the questions. So here we will take some questions related to different integral. So here we will understand that if you apply the conventional approach, so how it will take time. But if you go for some properties, so we will deal actually some properties of the different integral. So let us start with the questions. So here we will take the one question. I is equal to x sin square dx 0 to pi, and second question we will take I is equal to 0 to pi x cos square dx. So here we will apply actually Euler rule. So we have to describe first of all Euler rule. I-L-A-T-E. So I is a inverse function, N is a stands for the logarithm function, and A is a algebraic function, and T is a trigonometric function, and E is a exponential function. Okay. So I hope you will understand that. Like I stands for the inverse function, and L stands for the logarithm function, and A stands for the algebraic function. T stands for the trigonometric function. E stands for the exponential functions. So how to deal with, like if you have two functions which are in product, so how to take the property, which function we have to take the first function and second function. So based on that we have to take it. Okay. So here like x is my algebraic function, so we'll take like algebraic function, and t is a trigonometric function, we'll take the second, and this is my first, like that. So this way we will able to make the property to choose the which function is the first function, which function is second function, using the Euler rule. So here like I is equal to x sin square dx 0 to pi. So we have to apply the Euler rule. So what is my first function is x, this is my algebraic function, and sin square x, this is my trigonometric function, we consider the second function. So here what is the Euler rule? We have to extend first of all Euler rule. So this is my first function, this is my second function. So we have to deal with f into x, and integration of the second function minus integration first function, we have to derivative into integration of the second function or whole integration. This way we have to extend this formula. So here we have to apply this formula in the first question, 0 to pi x sin square x dx. So here is my first function, this is my second function. So here x into integration of the sin square x minus first function derivative into integration of the sin square dx and whole integration. Then x into integration of the sin square dx minus x, this will be 1. Hope you will understand that derivative of the x will give the 1 into integration of the sin square dx and whole dx. So here we have to split this function, like we have to first the integration of the sin square x. So directly we cannot solve it, because we know the integration of standard function like sine, cos, tan. We know the integration. So we have to convert this given problem in the standard functions. We are familiar with the integrations. So like formula like cos 2a this formula is a cos square a minus sin square a. And similarly, if you apply this theorem like this, if cos square a minus sin square a equal to 1, if you apply here, we have to find out the cos 2a in terms of the sin only. So 1 minus 2 sin square a. And same way we can also solve in terms of the cos only, 2 cos square a minus 1. This way we can find out this formula we have to use here. Like we know here cos 2a equal to minus cos 2a is equal to 1 minus 2 sin square a. So what is a sin square a? If you find out, we'll get 1 minus cos 2a by 2. Okay. So here my variable is x. We have to write in the x only. So here we will have to get it 1 minus cos 2x by 2 dx. Then it is very easy to find out, right? Because we know that 1 by 2 you can take outside, and 1 minus cos 2x into dx. So 1 by 2 here, if you this is a linear actually operator, my integral is a linear operator, you can use separate function like that. You will get 1 by 2 x minus, you will get sin 2x by 2. Hope you understood. So you will get this answer. Okay. So what is my main integration? I is equal to, we have to assume this is my equation 1. Okay. Later we will apply the limit also. Okay, lower end limit. So here what is the x into, this is my value. What is the value? 1 by 2 x sin 2x by 2. 1 by 2 x minus sin 2x by 2. And then second term minus integration of the, this integration we have to find out. So we'll get the 1 by 2 ax minus sin 2x by 2 dx. So this we have to already find out the integration, but again we have to integrate this. So here we can find out this is you can multiply minus one by 2 integration of x minus sin 2x by 2. This is my dx. We have to apply dx. Okay. So x square by 2 minus x sin 2x by 2 minus 1 by 2 x square by 2 plus 1 by 4. We will get 1 by 4 cos 2x by 2. Again we have to do that, but here cos here should be minus, here should be then, because we know that in case of the integration of the sine, we'll get the minus cos x. So minus, so you will get the x square by 2 minus and minus x square by 4 and then minus 1 by 8 cos 2x. Then here we can apply the limit. So pi upper limit minus lower limit. So pi square by 2 minus, here you get pi into sine 2 into pi by 2. You know sine 2 into 2 pi will get the 0. But it is a sine waveform like that. So this is my pi by 2. Sorry, pi. This is my 2 pi. So you can see here 0. This value will get the 1 and minus 1. You know the sine graph, sine x, this is my x. So you can see that here in case of sine graph, the at 2 pi you will get the 0 value. Okay, so here will get the 0 value. There is no need to write minus. You will get the here pi square by 4 minus 1 by 8 cos 2x pi. What is a 2 pi value? This is my cos function. This is my 2 pi. You will get 1 value. So you will get the 1 value. Understood me? So and then minus lower limit. This will 0. This is 0. This is also 0. And you will get the minus 8. This is 0. Minus 0. Minus 0. Minus 1 by 8. Okay. We have to go next page. So you will get pi square by 2 minus pi square by 4 and minus 1 by 8 minus minus plus. This will be cancelled out. Huh? Minus 1 by 8 minus plus 1 by 8 will cancel out. Okay. So you will get pi square by 4. This is my answer. Okay. So here I haven't applied the different integral property. So it will take time to solve. First we have solve the whole integral and then we apply the limit. But if you try to apply the different integral property, so it will be easy to solve this question. Let us see whether we will able to match this answer or not. Here we have to also state some property. You know that fx dx 0 to a 0 to a f a minus x dx. It will be answer will be same, a minus x, and 0 to a ax f x minus dx. You will get the otherwise a by 2 fx dx 0 to a. Okay. So here otherwise do one thing. You will like 0 to a f ds. We apply the same property here, and we will find out this whether it is correct or not correct. Let us see. So, but how to apply here? This should be equal. Fx is equal to efa minus x. If you put it should be equal. Then this property we can use it. Okay. So like in case of 0 to a, ax, a minus x into f a minus x dx. I am applying this property. This will be equal to the 0 to a x fx dx. Then you know that 0 to a f a minus x dx. This will be same property. You will get here fx. You will write here, because this property we can use only when fx equal to the f a minus x. Then we can use it. So here is a integration 0 to a f fx dx. We will get the 0 to a and minus, sorry, here a into minus x also, then minus x 0 to a f a minus x dx, second term. So equal to, we will get the 0 to a fx. Here we have to substitute fx is equal to f a minus x. If you apply, you will get the same function a minus x. You get the same function plus, sorry, minus n minus x 0 to a fx dx. We substitute f a minus x equal to fx. We have to take this term in left hand side. So 0, this is same function, no? This function is a same itself same function. So we'll get the 2 0 to a f fx dx equal to 0 to a 2 into a fx dx. Then f dx 0 to a, you will get the, here a na, a you can take outside, 0 to a fx dx. Here is 2 and you will divide here 2. So this is very good property, very effective property in terms of eliminate the algebraic function. So here we have to generalize this property, like earlier we have taken 0 to a, we have to take here a to b, and here is ax f at dx. You will take here a to b, then take a plus b by 2 into fx dx. Same way. Or this is only applicable when f a minus is equal to fx itself. Okay na? Hope you will understood that. So here my problem here, a has the 0 itself, so there is no problem. But if you have a 0 not there, then you have to consider the 0 lower limit also, a plus b by 2. Okay. So here, so let us solve using this property. My question is 0 to pi ax sin square dx to I. So here function is a sin square x. Then here we have to use a is a 0, b is a pi. So a plus b. Here one more thing here. Here a minus x not there. Here a plus b. We have to add the lower and upper limit minus x. It should be equal to function itself. Then we have to apply this property. So here 0 plus pi itself minus x. So 0 pi minus x, you will get sin x square, same function itself. So hence we are able to apply this property. So here I is equal to x, we can take outside, and what is your property? You can see here 0 to a fx dx. So what is a here? Pi. So a plus b by 2, a is 0, b is pi. So pi by 2, 0 to pi sine square x dx. So here you can use the sine square in terms of cos. So cos 2x by 2, 0 to pi dx. Let me check color. So pi by 2 and then 1 by 2, we are applying the integration 1 by 2x, and here sine 2x by 4, 0 to pi. So here pi by 2, here is a, what is my pi by 2, here is a xy, x by 2 minus sine 2x sine 2x by 4, 0 to pi. So let us see. We apply the upper limit. So sine 2 pi by 4, sine 2 pi, we have seen earlier also. This is my graph, sine graph. This is x. This is my value pi by 2, this is 0. This is my pi, this is my 2 pi. Okay. This is periodic function. This is minus 1. Sin x has a range minus 1 to 1, and we'll get the 2 pi, we'll get the 0 value. Okay. So here pi by 2, remember this graph, waveform for sin x, very easy to memorize the value of the sin x for the specific angles on the specific angles. Okay, so here pi by 2 sin 2 into pi, you will get the 0 minus, we have to apply the lower limit, this is also 0. So we'll get the pi square by 4. So here you can see here there is no need to apply the Eilert rule at all. Earlier you have seen here, if you approach the conventional approach, like apply the Eilert rule, and we have to solve, and then it will take time, but it is solvable, not possible. It is not like that it is not possible, but it will take time. But if you use this different integral property, so it is very easy to solve. Okay. So I hope you all of you have understood, and same way we have solved and we have learned here the concept and this property actually through this question, how it is helpful to solve this questions. Okay, so okay, so that is all for today session. So hope you enjoy. So thank you.